Higher section 2, example 1. If cos 2x equals 7 over 25, find the exact values of cos x and sin x. This is a non-calculator equation. Now, what I can do with the double angle there is I can use one of my formulas to help me get going. So one of the formulas in the formula sheet is 2 cos squared x minus 1. So cos 2x equals 2 cos squared x minus 1. So therefore I can say that that's equal to 7 over 25. I'm going to bring that over, and that's 2 cos squared x is equal to 7 over 25 plus 1, which is 25 over 25. So I've now got 2 cos squared x is equal to 32 over 25. I'm then going to divide that by 2. So 32 25ths divided by 2 is 16 25ths. For cos x, I then take the square root. So square root of 16 over 25, square root of top and bottom gives me 4/5. So that's my value for cos x. Next thing the question is asking for is to find sin x. Now remember, if you've been given one of your trig ratios, what you can immediately do there is draw a triangle. So you've got your angle x, and you've got the adjacent is going to be 4, and the hypotenuse will be 5. Through Pythagoras, that other side is 3. For sin of x, then it's just opposite over hypotenuse. So it's going to be 3 over 5. That's the question done. Section 2, example 2. Using the fact that 7 pi over 12 equals pi over 3 plus pi over 4, find the exact value of 7 pi over 12. Well, the question is telling me really what to do to get started there. It's telling me that to think about sin 7 pi over 12 is sin pi over 3 plus pi over 4. There's only one route to go there, which is the addition formula for sin a plus b. So the sin plus expansion is sin cos plus cos sin. So that's sin pi over 3, that's a non-calculator equation, cos pi over 4 plus cos pi over 3 sin pi over 4. So I'm going to write in radians but think in degrees. So pi over 3 is 60, pi over 4 is 45. So sin of 60 is root 3 over 2. I'm multiplying that by cos 45, which is 1 over root 2, plus cos of 60 is 1/2, multiplied by sin of 45, which is 1 over root 2 again. So multiply top and bottom, root 3 times 1 is root 3, and that's over 2 root 2, plus 1 over 2 root 2. I can then put that together, that's root 3 plus 1 over 2 root 2. Okay, part B says, show that sin a plus b plus sin a minus b equals 2 sin a cos b. So sin a plus b plus sin a minus b. So this is pretty easy. Just take what you've got and expand it out. So sin a plus b is sin a cos b plus cos a sin b. I'm then adding on sin a cos b minus cos a sin b. Okay, so I've got sin a cos b plus sin a cos b is 2 sin a cos b. Cos a sin b minus cos a sin b cancels out, and there's my final answer. Okay, part C says express pi over 12 in terms of pi over 3 and pi over 4. Right, well, there's just a wee bit of experimentation with this in fractions, but you should find that 1/3 minus 1/4 is equal to 1/12 if you just play about with it. So lowest common denominator there is 12, so top and bottom be 4, top bottom be 3. 4/12 take away 3/12 is 1/12. So the same can be applied for these. So pi/12 is just pi/3 minus pi/4. Hence or otherwise, find the exact value of sine 7 pi/12, which I've already got, so I'll take care of that later on, plus sine pi/12. Well, sine pi/12 I'm now going to write as sine pi/3 minus pi/4. So again, it's just a sine expansion. So sine minus expansion is sine A cos B minus cos A sine B. So it's going to be sine pi/3 cos pi/4 minus cos pi/3 sine pi/4. So sine of 60 is √3/2 multiplied by cos 45, 1/√2 minus cos of 60 is 1/2 multiplied by sine of 45, which is 1/√2. So multiply top and bottom. √3 times 1 is √3 over 2√2 minus 1/2√2, which can now be written as √3 minus 1 over 2√2. So now I just add both results together. So √3 plus 1 over 2√2, and that was for sine 7 pi/12, plus my result for sine pi/12 was √3 minus 1 over 2√2. So that's √3 plus 1 minus 1 all over 2√2. So that's 2√3, they two cancel out, over 2√2, they two cancel out, and it's √3 over √2. I could rationalise the denominator, which is getting rid of the root sign, by multiplying top and bottom by √2. So √3 times √2 is √6. √2 times √2 is 2, and that's the final answer.